Imagine you're standing backstage at like the most complex, chaotic, brilliant light show ever created.
Wow, okay.
Yeah, and you can hear the crowd just roaring on the other side of the curtain, right? You can
Ah.
see the blinding flashes of neon bleeding through the fabric.
Right, the whole spectacle.
Exactly. And pop culture, well, when it talks about psychedelics, it almost exclusively focuses on that side of the curtain.
The show itself.
Yeah, the colors, the
Yeah.
geometric patterns, the melting walls, the wild subjective experience of the trip happening out in the crowd.
Which is fascinating, but it's not the whole story.
Not even close.
Mm.
Because for you and me today, we're completely ignoring the light show.
We're going behind the scenes.
We are walking deeper backstage, past the cables, past the scaffolding, and we're finding the main electrical panel. We're zooming in on the exact microscopic physical ignition switch that turns the whole thing on.
I love that. We're tracing a path from just a single molecule fitting into a single receptor all the way up to like the fundamental altering of a person's ego.
And their mental health, too.
Exactly. Because this topic perfectly bridges the invisible world of cellular biology with, well, the incredibly profound macroscopic experience of human consciousness.
It really does. And our map for this backstage tour is this truly fascinating Substack post by someone named SpiralSeekr.
Right, the role of the 5-HT2A receptor in psychedelic pharmacology.
Such a great piece. And the mission for this deep dive is to demystify the hardcore neuroscience of exactly how these substances work in the brain.
And why they're, quite frankly, revolutionizing the treatment of severe depression and trauma.
Yeah, but to understand that clinical revolution, we have to start at the physical ignition switch, keyhole.
The 5-HT2A receptor.
Right. So this is a G protein coupled receptor, and its normal everyday job is just to bind the endogenous neurotransmitter serotonin.
The natural serotonin, yeah.
Yeah.
The stuff your body just makes all on its own.
Exactly. But where do we actually find these things?
Well, in the human central nervous system, these 5-HT2A receptors are expressed at like incredibly high densities in the neocortex.
Okay, the neocortex.
Yeah, and specifically, they're located on the apical dendrites of layer V pyramidal neurons.
Layer V pyramidal neurons. Okay, so if we picture the neocortex as the folded outer layer of the brain.
Right, the part responsible for higher-order thinking.
Exactly. So these layer V neurons are basically the heavy lifters. They're the major output neurons.
Yeah, they take all that complex processing happening up in the cortex, and they send those signals down to other critical parts of the brain.
And you also find these receptors in the claustrum, the thalamus, the basal ganglia.
Yeah, all those areas. But in the cortex, the primary function of these 5-HT2A receptors is excitatory.
Which means they promote activity, right?
Exactly. If you think of your brain's neuronal network as like a massive complex sound system, the 5-HT2A receptor acts as an excitatory volume dial.
I like that analogy. So activation turns up the gain.
It does, specifically by modulating the release of other neurotransmitters. And the most prominent downstream effect here is the release of glutamate.
Which is the brain's primary excitatory chemical, right?
Yeah. You got it. So the entire localized network just becomes more active, more prone to firing, and way more sensitive to input.
Okay, so when we talk about classic psychedelics, substances like LSD, DMT, mescaline,
and psilocin, which is the active compound your body makes when you ingest psilocybin mushrooms.
Right, psilocin. So these substances exert their primary hallucinogenic effects by acting directly on this receptor.
Yeah, they act as agonists, or, well, partial agonists.
Meaning they physically fit into that 5-HT2A keyhole and twist the volume dial up.
That's exactly what they do.
But wait, I have to jump in here with a skeptical question.
Go for it.
The human brain has nearly 100 billion neurons, right? And thousands of different receptor types interacting in this impossibly complex soup of chemistry.
Oh, yeah, it's incredibly chaotic.
So how do we know for sure that this specific receptor, the 5-HT2A, is the undisputed cause of the hallucinations?
That's a great question.
Like, couldn't the LSD or the psilocin be triggering, I don't know, a dozen other systems entirely that are actually causing the trip?
Well, scientists had to definitively prove that mechanism, and they actually did it in two major ways.
Okay, what's the first one?
If we look back at some foundational research by Glennon and colleagues, this was in 1984, they demonstrated that the behavioral potency of a classic psychedelic correlates perfectly with its binding affinity for the 5-HT2A receptor.
Wait, really? So they just tested a bunch of them?
Exactly. They tested various compounds and found that basically the tighter a specific molecule binds to 5-HT2A, the stronger the hallucinogenic effect.
Okay, but I mean, correlation isn't causation.
Right, right.
Just because the tightest fit produces the strongest trip doesn't rule out the drug doing something else in the background, you know?
Which brings us to the definitive proof, the Ketanserin block.
The Ketanserin block, what is that?
So Ketanserin is a 5-HT2A antagonist. Instead of turning the volume dial up, it acts like a piece of heavy-duty duct tape stuck firmly over the keyhole.
Oh, wow. So it binds to the receptor but doesn't activate it.
Exactly. It prevents anything else from getting in.
Okay, so how do they use that to prove it?
In clinical settings, researchers administer Ketanserin to human subjects first, and then after that, they give them a high dose of a classic psychedelic like psilocybin.
Wait, and what happens?
The result is a complete absence of the psychedelic experience.
Really? Nothing happens.
Nothing. It entirely blocks the subjective, cognitive, and behavioral effects. The person just sits there.
Wow. So because the receptor is blocked, the trip never starts.
Exactly. Which confirms this specific receptor is the absolutely necessary biological gatekeeper.
No 5-HT2A receptor, no psychedelic experience.
Yeah.
But, okay, that introduces a massive, glaring paradox.
I think I know where you're going with this.
If classic psychedelics bind to the exact same receptor as our brain's natural, everyday serotonin,
Right.
why doesn't normal serotonin cause us to hallucinate? I mean, my brain is releasing serotonin right now as we speak, and the walls aren't melting, right? Time isn't dilating.
And your ego is very much intact, presumably.
Exactly.
Yeah.
So what is the physical difference?
Well, the answer requires looking past the keyhole and seeing the actual machinery inside the cell.
Okay, lay it on me.
When a molecule binds to the outside of the 5-HT2A receptor, it causes a conformational change.
Meaning the receptor physically alters its 3D shape.
Yes. It twists and bends through the cell membrane, and this mechanical twist activates associated G proteins that are just waiting on the inside of the cell.
Kicking off an intracellular signaling cascade.
Exactly.
I always picture it like a microscopic Rube Goldberg machine.
Oh, that's perfect.
Like a marble drops in the top, hits a lever, which knocks over a domino, which swings a pendulum.
That is exactly what it's like. The canonical pathway inside the cell involves a specific protein that, when activated by the receptor's shape change, acts like a pair of molecular scissors.
Molecular scissors, what are they cutting?
It finds a specific lipid in the cell membrane and cleaves it into two distinct fragments. And those two new fragments suddenly become active messengers.
Okay, so the dominoes are falling.
Right. One messenger plunges into the cell and triggers a massive release of stored calcium, basically flooding the internal environment.
And the other one?
The other messenger stays near the membrane and turns on a different set of cellular engines. It activates enzymes that alter how the neuron behaves.
And that is the standard, everyday chain reaction for serotonin.
No, exactly.
But if serotonin and psychedelics both drop the marble into this same Rube Goldberg machine, we are still stuck on the paradox.
Right. Why the hallucination for one and not the other?
Yeah. Why?
Because the machine has hidden tracks.
Oh, okay.
This brings us to a phenomenon called biased agonism, or functional selectivity.
Functional selectivity. Okay, what does that mean?
So when natural endogenous serotonin binds to the 5-HT2A receptor, it acts like, well, an unbiased manager.
Unbiased.
Yeah, it causes a specific conformational shape change that activates multiple intracellular pathways equally. It triggers that standard calcium flooding pathway we just discussed, but it also triggers others, keeping the internal cellular response balanced and predictable.
So serotonin turns the key, the door opens, and all the lights in the house turn on equally.
That's a great way to put it. But psychedelics use a sort of secret handshake at the receptor.
A secret handshake.
Yeah, because the molecular shape of LSD or psilocin is slightly different from natural serotonin, the conformational twist they cause in the receptor is physically different.
So it contorts the receptor into a unique geometry.
Exactly. And this unique shape preferentially activates distinct, highly specific signaling cascades inside the cell while, largely ignoring others.
Wow. So it's heavily biased.
Right. Research shows they can heavily bias toward entirely different messenger pathways, like the auristatin-2 pathway.
Okay.
Or this unique shape change causes the 5-HT2A receptor to physically link up with completely different receptors nearby, forming a complex.
Like what?
Like the 5-HT2A and mGlia-R2 complex, which changes the neuron's firing behavior entirely.
So the receptor is not just a simple on-off switch.
No, not at all.
It's a highly sensitive, multi-dimensional control panel. And the psychedelic drug presses a highly specific combination of buttons, a secret handshake that normal serotonin cannot replicate.
Yes. That specific shape-shifting cascade inside the cell is what creates the distinct hallucinogenic outcome.
Okay, I understand the mechanics of the secret handshake.
Good.
But, my ego, my sense of self, isn't contained in a single cell.
Yeah.
I'm having trouble making the leap in scale here.
How so?
How does a microscopic biased chemical cascade involving calcium and internal messengers echo loudly enough across the brain to completely shut down someone's sense of self?
Ah, right. How does it alter their entire perception of reality?
Yeah, exactly.
Well, the downstream effect of billions of these specific 5-HT2A receptors being activated simultaneously is a profound alteration in macroscopic brain network dynamics.
Okay, zooming way out.
Right. And this is where functional magnetic resonance imaging, or fMRI, totally revolutionized our understanding.
Oh, I've seen some of this.
Yeah. Robin Carhart-Harris and his colleagues conducted pioneering research in 2012 and 2016, literally putting subjects in fMRI scanners while they were under the acute influence of psychedelics.
Literally watching the light show from the control room in real time.
Exactly. And the scans revealed an unprecedented disruption.
What kind of disruption?
The administration of the psychedelic led to a complete dissolution of established rigid cortical networks.
Wow.
And the most critical system affected is the default mode network, or DMN.
The DMN. Let's talk about that.
It's essentially a heavily trafficked superhighway of interacting brain regions that are highly active when you're awake, but not focused on the outside world.
So like when you're introspecting.
Right. Self-referential processing, daydreaming about your past, worrying about your future.
It's the narrator in your head.
Exactly.
Yeah.
Fundamentally, neuroscientists consider the DMN to be the biological seat of the ego.
The biological seat of the ego. I like to conceptualize the default mode network as a strict, micromanaging corporate office manager.
Okay, let's hear it.
Imagine your brain is a massive corporation with specialized departments, vision, hearing, memory, emotion.
Sure.
Normally, the DMN office manager is relentlessly patrolling the hallways with a clipboard, keeping everyone perfectly in their lane.
Right, no unauthorized socializing.
Exactly. The vision department is never allowed to talk directly to the emotion department without routing a memo through proper channels. The manager keeps the established networks highly segregated, predictable, and orderly.
And that continuous, tightly controlled narrative is your normal, sober sense of self.
Right. But what happens to the manager under psychedelics?
What Carhart-Harris's fMRI scans visually proved is that under the influence of the psychedelic, that strict office manager is acutely suppressed.
He gets sent home?
Pretty much. The network physically loses its cohesive blood flow and connectivity. The manager is forced to take the day off.
And with a manager gone, the departments inevitably start talking to each other.
Oh, big time. Concurrently with the suppression of the DMN, the fMRI scans show a massive, explosive increase in what's called global functional connectivity.
Global functional connectivity.
Yeah. Normally, segregated functional networks become highly interconnected. Regions of the brain that almost never communicate directly suddenly strike up intense, unfiltered conversations.
Which creates a state of high brain entropy.
Exactly.
Now, brain entropy. In thermodynamics, entropy usually means chaos or disorder, right?
Usually, yeah.
But in neuroscience, it sounds like it means maximum flexibility. The rigid constraints are gone, allowing for an incredibly fluid state.
That's spot on. Entropy here refers to an exponentially higher number of possible states the brain can occupy at any given moment.
Wow.
It's a state of profound fluidity, temporarily dissolving rigid, hardwired patterns, and allowing for entirely novel connections to form across the brain's macroscopic landscape.
Which perfectly explains the subjective effects people report, like synesthesia, where a person might, see a sound or taste a color. The visual and auditory departments are having a direct, unfiltered conversation without the DMN manager there to regulate the signals.
That's exactly what's happening on a network level.
But here's the million-dollar question for anyone tracking the clinical applications.
Let's hear it.
This high-entropy state, this wild, interconnected office party in the brain, it's temporary.
Very temporary.
The drug is metabolized by the body. Usually within 6 to 8 hours, it wears off, and the strict office manager comes back to work.
Right.
So, how is it biologically possible that patients report life-altering benefits, like massive shifts in their depression months or even years later, from a drug that is entirely gone from their system by dinner time?
That is the crucial question. And the clinical magic doesn't reside solely in the acute trip. It resides in the biological aftermath of that high entropy state.
Yeah, aftermath.
Yeah. Sustained 5-HT2A activation during that acute window initiates a cascade of long-term neuroadaptations. Research published by Lai and colleagues in 2018 demonstrated that classic psychedelics promote profound structural and functional neuroplasticity.
Neuroplasticity.
Yeah.
So the brain's ability to physically rewire itself to forge new pathways.
Right, but not just shifting a few resources around. We are talking about generating actual physical growth.
Like growing new brain cells.
Well, the psychedelics trigger the upregulation of brain-derived neurotrophic factor, or BDNF.
BDNS.
Yeah, which acts like a highly potent fertilizer for neurons. They also activate the mTOR signaling pathway, which is a master regulator of cellular growth and protein synthesis.
The Substack piece highlights what I like to call the Genesis trio, because this chemical fertilizer literally gives birth to new physical architecture in the brain.
The Genesis trio, I like that.
Yeah, the research points to 3 distinct physical changes: neurogenesis, spinogenesis, and synaptogenesis.
You want to break this down?
Sure. So neurogenesis is the actual physical sprouting of new neurites, the branches reaching out from the main body of the neuron.
Right.
Spinogenesis is the creation of new dendritic spines, which are the tiny receiving hubs popping up along those new branches.
Exactly.
And synaptogenesis is the forging of entirely new synapses, basically locking in physical communication channels between neurons that didn't exist yesterday.
It's incredible.
The brain isn't just changing its mind in an abstract psychological sense. It is structurally growing, becoming physically denser with connections in the days and weeks following that 6-hour experience.
And that physical structural growth is the enduring legacy of the transient chemical event. The drug leaves the system, but the new biological wiring remains.
It's like a software update that upgrades the hardware.
Exactly. This unparalleled capacity to induce rapid, sustained neuroplastic changes forms the primary biological foundation for why we're currently seeing a renaissance of clinical trials.
Using psychedelics for treatment-resistant depression, PTSD, and addiction.
Yes, all of those.
So let's look at what happens when we take this newfound, tangible brain plasticity and apply it to people suffering from deeply entrenched mental health conditions.
The clinical trials.
Yeah, how do these biological mechanisms actually perform in human trials?
The data over the last decade has challenged so many fundamental assumptions in psychiatry.
Like what?
Consider the landmark study by Griffiths and colleagues in 2016. They recruited patients with life-threatening cancer diagnoses.
Oh, wow. Individuals dealing with profound, paralyzing existential anxiety.
Right, and depression regarding their mortality. They administered a single high dose of psilocybin in a carefully controlled therapeutic setting.
And what did they find?
The data showed a rapid, massive decrease in both depression and anxiety scores. But what astonished the psychiatric community was that this profound symptom remission persisted strongly at the 6-month follow-up mark.
6 months from a single acute intervention.
Yes, resulting in 6 months of sustained psychological relief.
That timeline is practically unheard of with traditional psychiatric medications. I mean, those usually require weeks of daily dosing just to build up a therapeutic effect.
Exactly, and the clinical landscape has only accelerated since then. There's a highly publicized trial comparing psilocybin directly to those standard daily medications.
Right, the 2021 Phase 2 randomized controlled trial led by Robin Carhart-Harris.
That's the one. This study directly pitted psilocybin therapy against escitalopram, which is a standard, widely prescribed SSRI antidepressant for patients suffering from major depressive disorder.
And how did they compare?
Over a 6-week period, the data showed that psilocybin was statistically non-inferior to the daily SSRI for the primary outcome of reducing depressive symptoms.
Non-inferior, okay.
But crucially, psilocybin was generally superior across a range of secondary measures.
Really? Like what?
Patients reported greater psychological well-being, increased meaning in life, and enhanced emotional responsiveness.
That's a huge deal.
It is. It directly contrasts with the emotional blunting, the feeling of being numbed out that is so frequently reported as a side effect of long-term SSRI use.
So a single or double dose of a compound that actually increases emotional responsiveness, outperforming a daily pill that often numbs the patient.
Basically, yes.
But we have to be extremely clear here. The Substack source emphasizes that this is not a magic pill.
Oh, absolutely not.
You don't just take a psychedelic in a vacuum, grow some new brain branches, and magically cure depression, right?
Right. The clinical efficacy relies entirely on a specific model of how biology and psychology intersect.
And that intersection is articulated perfectly in the synergistic model proposed by Davis and colleagues in 2020.
Let's talk about that model.
It frames conditions like major depression, OCD, and addiction as ruminative disorders.
Yes. They are characterized by incredibly rigid, maladaptive cognitive patterns.
Like the default mode network, that strict office manager has essentially become a tyrant, forcing the brain to endlessly loop the same negative, destructive thoughts.
Exactly. I am worthless, nothing will ever get better, or I cannot survive without this substance.
The behavioral grooves in the mind are cut so deep that the needle is permanently stuck, playing the same agonizing track over and over.
And this is where the biology comes in. The transient 5-HT2A activation acutely destabilizes those rigid, tyrannical patterns.
By suppressing the DMN and increasing brain entropy.
Right. The drug violently lifts the needle out of the groove, and this provides what Davis terms a critical window of neuroplasticity.
Let me try to synthesize this mechanism because the synergy here is brilliant.
Go for it.
The biological window of physical brain plasticity, all that BDNF fertilizer and new synapse growth, occurs at the exact same time the patient is experiencing a high degree of subjective personal meaning.
Yes. During the trip, patients frequently report feeling a deep sense of universal connection, or they're processing repressed trauma, or achieving sudden existential clarity.
And they take that profound psychological experience and they use the biological window of plasticity combined with intensive professional psychotherapy before and after the dose to completely restructure their cognitive frameworks.
That's the key.
It is like a blacksmith fixing a bent sword.
Oh, another analogy.
Can't help it. The psychedelic drug is the fire that heats up the rigid metal until it is glowing and malleable. But the heat alone doesn't fix the sword.
No, you need more than heat.
Exactly. The professional psychotherapy, combined with the patient's own deeply meaningful insights from the trip, those are the hammer and anvil. They actively reshape the cognitive metal into a healthier functional form before the window of neuroplasticity closes and the metal cools down again.
That is a perfect way to visualize it. The biological mechanism creates the physiological opportunity, but the psychological experience and therapeutic integration dictate the clinical outcome.
It's a true, inseparable marriage of chemistry and meaning.
You cannot achieve these dramatic clinical results with just the biological hardware changes, nor can you achieve them with just talk therapy against a rigid, unyielding DMN.
The therapeutic breakthrough requires both.
Exactly.
Well, we have covered a massive amount of incredibly dense science today.
We really have.
We walked backstage and found the specific ignition switch, tracing the path from the single 5-HT2A receptor located on the apical dendrites of layer V pyramidal neurons.
We explored the secret handshake inside the cell.
Right, where biased agonism triggers a unique, shape-shifting cascade of internal messengers instead of the normal serotonin response.
And we zoomed out to watch the strict, micromanaging corporate manager of the default mode network lose its grip,
Flooding the brain with entropy and global functional connectivity. We unpacked how the Genesis trio physically regrows the brain's hardware long after the chemical has been metabolized.
which is so crucial.
And finally, we saw how that highly malleable state, when paired with structured therapy, is creating profound, enduring breakthroughs in clinical trials for severe depression.
You know, the science we've explored today represents a monumental shift in neuropharmacology. This isn't about escaping reality or chasing a visual light show. It's about temporarily altering the biological hardware so the human mind can find a healthier, less rigid way to process reality. We are moving far beyond subjective anecdotes and firmly into the realm of measurable physiological transformation that can alleviate profound human suffering.
It is a massive leap forward for mental health. But I want to leave you, the listeners, with one final, slightly provocative thought to mull over.
Oh, I'm curious.
We started this deep dive talking about finding the purely mechanical biological cause of the psychedelic experience. A lock, a key, a release of calcium, a suppression of blood flow in the DMN.
The physical mechanisms.
Exactly.
Huh.
But if the profound, deeply spiritual meaning that patients report, The visions, the encounters with repressed grief, the sudden understanding of their place in the universe is fundamentally just the subjective side effect of a specific receptor temporarily increasing brain entropy.
All right.
Does that biological reductionism make the meaning any less real? Or is our biology, honed by millions of years of evolution, simply providing the physical keys to unlock genuine psychological truths that were waiting in the dark all along?
That's quite the question to leave them with.
Well, thank you for joining us on this deep dive. Keep exploring, keep questioning the world around you, and we'll see you next time.